Hello friends, in the last lecture we discussed about instruction set design issues and different types of operations and what operations are included in which types that we discussed in our last lecture. Today we are going to discuss about addressing modes. Uh, Addressing modes means how to access your operand from your memory. How to fetch that required operand. For that we have different ways, and these are different 7 ways. In these different ways we can get the required operand from your memory into your processor. Okay, so and this is called as addressing modes. Okay, so first addressing mode is immediate addressing mode. See, as you can see here, this is your instruction format. The instruction format depends upon the type of processor you are using, and the number of fields will also be different based upon your processor and instruction set. So here I'm just going to consider one field for opcode and one field for operand, and it's in some cases it's address. This is just for example. See, here you can see that in instruction itself the operand will be specified. So the processor doesn't have to go to memory and fetch the operand, doesn't have to do all these operations. What the operand is there itself in your instruction register after fetching the instruction in instruction register. So that acts, the operand is immediately available after fetching the instruction. This is called as immediate addressing mode. Now, how will you know whatever there is in that field, whether that is operand or whether it's an address? For specifying that, so we have to specify that which addressing mode is being used in that particular instruction. For that, again, we need to assign few bits. We need to allocate few bits for that addressing mode. Now, see here we have 7 different types of addressing modes. And for specifying 7 different addressing modes, we are going to need minimum 3 bits allocated for specifying the addressing mode uniquely. Okay, so this was all about immediate addressing mode. Now, next addressing mode is direct addressing mode. Here, what you are going to do is in instruction, this part will be your opcode, and this remaining part will be address of your operand which needs to be fetched from your memory. Okay, so here the memory, the address of memory location from which the operand should be fetched, that is specified. And that's why it is called as direct addressing mode, because directly address is available in your instruction. Okay, now I hope you remember what happens to this instruction. After the instruction gets fetched from your memory, it gets copied into your instruction register. Then this part gets copied into your memory address register, and from memory address register, the, the address is accessed, and from that address, from that specified address, the operand is fetched from your memory, and that operand is stored in your memory buffer register. Okay, so this is your direct addressing mode. Now let's talk about indirect addressing mode. Here you just have to remember address of address. Okay, address of address. This was operand's address. Here you have addresses address. Okay, so this will specify address Uh, this is the address of location where the actual address of your operand is stored. Don't Please don't get confused. This is the address of